Good afternoon and welcome back to the course. So, earlier this week, we broached the subject of the history of life on Earth and the what we can learn about the history of life on Earth from the fossil record, among other things. And what I wanted to do was to drill down into a particular case study, which is maybe my favorite animal on the planet, which is whales. So, the way that this series of vignettes will be organized is I'm going to start out by talking about whales in the fossil record with a bit of a historical introduction. And then the second part will be a second glimpse into history, but this time on the basis of DNA evidence. So, that's the plan of action. George Gaylord Simpson was one of the great paleontologists of the 20th century and a participant in what's now called the modern synthesis. This was if you like, the linkage between genetics and evolutionary biology and population genetics, which is more of a mathematical discipline, and how they all came together to provide a modern view of evolution, which included the paleontological work of Gaylord Simpson. So Darwin already was puzzled by the whale, although I have to say that in some sense, it's hard for me to, if I'm being empathetic, it's hard for me to get into his mindset. And what I mean by that is that, a trip to the seashore shows us otters and sea lions and, hippos in the freshwater context. There's a lot of animals, walruses, giant elephant seals, all these different things that where you feel like maybe you're watching, in slow motion, animals that have a sort of dual existence, a waterborne and also a landborne existence. Although the animals that just mentioned, I feel like in many ways are largely aquatic. But let's not quibble over it. My main point is just to say that Darwin puzzled over this. Note this is from chapter 6 of his book, which was called Difficulties on Theory. And I have to say that, I love this chapter because this is Darwin self-consciously critiquing his own work, which I think, there's few things that are better than that, is, being one's own harshest critic. Anyway, here's what he has to say. In North America, the black bear was seen by Hearn swimming for hours with widely open mouth, thus catching like a whale insects in the water. Even in so extreme a case as this, if the supply of insects were constant, and if better adapted competitors did not already exist in the country, I can see no difficulty in a race of bears being rendered by natural selection more and more aquatic in their structure and habits, with larger and larger mouths till a creature was produced as monstrous as a whale. So I am planning on thinking about two of the great transitions in the history of evolution on planet Earth, although the second of these will probably be thought of more in the context of readings than through vignettes. So that's fins to limbs. The limbs to fins refers to what happened uh, in the mammalian setting right after the extinction of the dinosaurs. So starting, let's say, 65 million years ago, there's a series of transitional forms that take us to what we now think of as modern day whales. So I want to just comment on, maybe this is bad on my part, but I can't help as in this moment of living through the global pandemic and watching the reaction, the conspiratorial mindset that we hear so often, where people seem reluctant to accept knowledge, that we can have knowledge and that there's a history of knowledge and that there is a record of the history of that knowledge. This is primarily just to say that, long before there were conspiracy theories about evolution, Herman Melville was telling us the situation on fossil whales. So he says, having already described him in most of his present habitatory and anatomical peculiarities, it now remains to magnify him in an archaeological, fossiliferous, and antediluvian point of view. Applied to any other creature than the Leviathan, to an ant or a flea, such portly terms might justly be deemed unwarrantably grandiloquent. It's still pretty and grandiloquent even here. Then he starts to tell us about the fossil record. And I thought the second paragraph here is very interesting, although above it you see, there have been many whale finds. But by far the most wonderful of all cetacean relics was the almost complete vast skeleton of an extinct monster found in the year 1842 on the plantation of Judge Cray. And then down here, he goes on to say, the Alabama doctors declared it a huge reptile and bestowed upon it the name of Basilosaurus. And you'll see this is going to figure into our discussion. But some specimen bones of it being taken across the sea to Owen, the English anatomist, it turned out that this alleged reptile was a whale, though of a departed species. A significant illustration of the fact, again and again repeated in this book, that the skeleton of the whale furnishes but little clue to the shape of his fully invested body. So Owen rechristened the monster Zeuglodon, and in his paper read before the London Geological Society, pronounced it in substance one of the most extraordinary creatures which the mutations of the globe have blotted out of existence. So I like that way of talking about the fossil record. The mutations of the globe have blotted out of existence. So I wanted to start with Georgia Cetus, and this is an example of what Melville was talking about in Moby Dick. Why? Because this is the southern United States, and this is modern, though. So I like this. I find this fascinating. Georgia Cetus was discovered in 1983 during the construction of the nuclear power plant, Plant Vogtle in Burke County, Georgia. The find consisted of 3 individuals, all identified as belonging to the same species. 2 of the individuals were represented by isolated bones recovered separately, which included a few vertebrae, ribs, and tooth crowns. The main find was discovered during the cutting of a drainage channel at a depth of about 30 feet below the surface. It was a 75 to 80% complete individual consisting of more than 60 bones and teeth, including a well-preserved skull and mandible. Fortunately, Georgia Power halted construction activities in the area and assisted in the recovery effort. The main mass was collected from an area about 3.3 meters square, but they were not articulated. There was evidence of light scavenging with scratches on one rib, but only 10 shark's teeth were recovered with the find. There was no duplication of fossilized bones in the main mass, so a single individual was represented. This was an adult animal with fully erupted and well-worn molars. There was no apparent cause of death. The main mass of bones were first reviewed in the field by geologist E.A. Shapiro of the Georgia Geologic Survey, which was abolished, with quotes on it, in 2004. So, I guess I'm going to be slightly politicized here, but part of the reason that I want to show this is that, as the students in the class already know, because they did a homework this past week on how we use radioactivity in order to date things on the history of the Earth, we also use radioactivity for the purposes of generating power. And I guess I just have always felt that science is not a smorgasbord. We don't get to heat our homes with nuclear power and then deny the ability to use that same radioactivity in order to date things. And I think it's just kind of an irony that, in the study of in the development of nuclear power in order to give people electricity in Georgia, they discovered a fossil whale which could be dated using the same radioactivity. This is strictly just to show you that there are a lot of fossils having to do with whales. I'm not going to comment on it any further, other than to point out that this guy Mark Ewan, who you're going to hear more about shortly, has done a lot of systematic studies of this. And I thought for those of you in LA that you'd be amused that one of our landfills actually has geologists in employ. So you can see there's a senior paleontologist, and they found whale fossils that I think, if I remember correctly, are like 10,000 years old at one of our waste dumps. So to talk of the whale, though, we really have to first remember the dinosaurs, because they're a part of our story. And I'll try to say what I mean by that. So we've already talked about, and the students have already actually developed their own impression of these different ways of characterizing the history of life on Earth. And out of that story included statements about index fossils, meaning that there were certain fossils that were present, and then in a relatively sharp boundary, those fossils no longer existed. And the thing that I want to pay attention to is the boundary you see here at 65 million years ago, when we no longer had ammonites. So the dinosaurs were on Earth a long time, and there's a rich fossil record for dinosaurs, which I'm not going to really comment on, but I do want to say, that I went to, in September of last year, I went up to Utah and Wyoming, and there's a place, I think it's called Fossil River, and it's just really impressive to go to these kinds of places where we've had such rich fossil discoveries. And so, there's skeletal morphology. This part's kind of mind blowing, which, like at the bottom, you see this nest of hatchlings. We have eggs. We have the microstructure of eggs. Even more impressively, in some sense, are these giant footprints and trackways. Same sort of thing you will see later in the term has been found in the context of human evolution or primate evolution and so on. And I also just wanted to point out, that it's easy to forget how long dinosaurs were around. They were around Triassic, Jurassic, Cretaceous, something like 150 or more million years. And then before continuing, I'm not going to have the opportunity to talk really about much besides whales here, but I wanted to call your attention to this guy, Jack Sepkoski, who's shown here with his dog. He was at the University of Chicago, and he was a paleontologist that actually used the computer and tried to synthesize data behind a desk. And out of that came this acknowledgement of these mass extinctions. So what's plotted on the y-axis is thousands of genera, and the dips that you see annotated with upside down yellow triangles correspond to the 5 big mass extinctions, with the Permian one, which is here at 250 million years ago or so, being perhaps the most significant. So it's very cool that we know something about the Earth at the time of the biggest mass extinctions, and probably many of you have seen these kinds of maps before, where we get in real time to examine continental drift. And I want you to notice this is 66 million years ago at the top, and I want you to notice this object, let's say off the east coast of Africa. You can see the eventual Madagascar, but also to the right of that in this picture, you can see what later will become India. So this chunk of land is moving north, and it gives a hint as to why so many whale fossils have been found in Pakistan. So I wanted to just say a little bit about the dinosaur extinction. So there's a hypothesis, which is that there was an impact in the Yucatan at this particular crater, and there may be some controversies that people would find interesting to think about. If we were in the classroom together, what I would do right now is have a guided struggle where the students would try to reconcile what they know about kinetic energy and about radius of asteroids and so on, to try to understand this graph on the left, which comes from this paper by Norman Sleep and company. And what's being plotted is you go from right to left as we're going backwards in history, and what we're looking at is the magnitude of asteroid collisions with the Earth, where the y-axis on the left side is telling us about the impact energy as measured in joules, which is basically determined both by the size of the asteroid and also by its speed, although for the simplest estimate we treat the speed of all of them the same. And if you go online, you can find all sorts of interesting things about the nature of the different impacts that have happened on Earth. And yeah, that's fun and interesting. And another thing that I would say came out of this is that there's very interesting chemistry. So there's a particular iridium signature at the KT boundary, which is meant to reflect, or I should say, is hypothesized to reflect this asteroid collision. So you can see here we're looking at a depth, and this particular spike has to do with an increase in the iridium. So, people think they found the crater and think of it as being causative with respect to the loss of dinosaurs. So what does this have to do with whales? Well, in a way, the angle that I'm going to take here is that with the extinction of the dinosaurs, an opportunity arose for mammals to do something different. And one of the different things that they did is to go back to the ocean. So let's now talk about the geological record. So chapter 9, another one of the classics on the origin of species. Chapter 6 is difficulties on theory. Chapter 9 is on the imperfections of the geological record. Note the tone of both of those chapters. Those chapters are self-critical. They're saying, Darwin is telling us, I have lots of really cool ideas. I have lots of really interesting data. I haven't solved everything about all problems, but I still think it's worthwhile to put this out there. And then he's self-critical. So here's what he has to say on the fossil record. I look at the natural geological record as history of the world imperfectly kept and written in a changing dialect. Of this history we possess the last volume alone, relating only to 2 or 3 countries. Of this volume, only here and there a short chapter has been preserved, and of each page, only here and there a few lines. Each word of the slowly changing language in which the history is supposed to be written, being more or less different in the interrupted succession of chapters, may represent the apparently abruptly changed forms of life, entombed in our consecutive but widely separated formations. And what I want to say is that in the meantime, the field of paleontology has put together a rich and exquisite record of life on Earth, and specifically with respect to whales. So in fact, what I would say is that, there could be an argument to think of the fossil record with respect to whales as not being so imperfect, but rather perfect. There's things that I want you to appreciate and take away from this. So one of the points that should become clear is the motion of the nostrils towards the rear, and that's signified by the skulls. But there's so many other things going on, like the loss of legs, and then there's things that we're going to understand about the ears and about echolocation and things going on at the level of the DNA as well. I wanted to say something. I wanted to just show this video because I find it so fascinating. It's a little out of place with respect to my discussion of the fossil record, but there's one sole reason that I want to show it, and let's see if I can advance the thing. So this guy, Frank Fish, he takes pictures of swimming cetaceans, dolphins, and maybe I'll just start right here and we can watch.
Fish swim by flexing their spines from side to side, like the shark. But mammals swim differently. This otter swims by undulating its spine up and down, in exactly the same way that whales do. And, as it turns out, in the same way that land mammals use their spines when running. Whales took with them into the water their ancestral way of moving, and we can still see it 50 million years later. The way they move.
I guess I just wanted to juxtapose for you. I find the video of the running dog to be very interesting, and then I find the swimming of the orca to be deeply moving. Can almost bring me to tears. It's so beautiful, I find, and the parallels between the two is so remarkable. So that's what I wanted to point out. So for those of you in the class, I can really highly recommend these 2 articles. One of them, the one by Ewan, is in Annual Reviews of Earth and Planetary Sciences, and the other one is from this guy, Thiwisin, who's also written a book. I don't know how to pronounce his name correctly, but these 2 articles, I think, are extremely rich sources for you to go do a little exploring. Here's what I'm going to do. Obviously, I'm no expert in this area. What I'm going to do is tourism, and it'd be a bit like tourism of the variety where, we go to New York City together, and maybe you haven't been before at all, and I've been there 25 times in my life. And, I have a vague notion of New York City, and I could show you around, and probably it could be fun. But to a New Yorker, I would probably sound very naive, and I fear that that's the case here. And there's a guy named Penniston who wrote a book about the whales that, he seems like a very good spirit guide for this stuff. So the first thing I want to comment on is this particular piece of equipment, which is called the astragalus. All modern and fossil artiodactyls are characterized by the presence of a double-pulleyed astragalus, one of the ankle bones, along with a suite of other morphological features. No other mammal has anything like this suite of features, and so we're going to come back to that. So, the even-toed ungulates, the artiodactyls, they have this particular signature, and we will see that it shows up in the fossil record. This figure from Ewan I like because it gives you a sense of the whale diversity and also where the whales were found at different times The bottom one is 52 million years ago. The middle one is, or the next one up is 42 million years ago. Then 36 million years, and finally 31. This is, again, tourism. This is just to inspire you to go read Ewan's article. This is a statement about, on the x-axis is number of cetacean genera, and the y-axis is time. And so we're just trying to get some sort of an idea about the diversity of cetaceans as a function of time. So what I'm going to do is I'm going to just walk you through, this collection of transitional forms. And we will try to look at them and see what we might learn about the fossil record. So I already commented on this, but I want you to note in the right-hand side the Indian subcontinent getting ready to collide with Asia and thereby create the Himalaya mountains. But it does imply something very interesting. It implies that when India collided with the main continent of Asia, what it did is it closed a sea. It closed what used to be a watery world. And so there's this guy, Philip Gingerich. I'm going to tell his story in a way that might not be quite right, and so I wish he were here to tell it for himself. But let's say that the idea of paleontologists might have been that they wanted to, in the fossil record, see the animals walking off of India into Asia. And the place to look for that would be at the interface between those two places. Well, what happened is Gingerich would go and do his paleontological work in Pakistan, and he would keep finding, and also in Egypt, he would keep finding whales. So the way I like to think of it, which is probably very romanticized and not really true, is that at some point he just said, okay, well, you have to answer the door when opportunity knocks. And so he became, this very profound worker in this area. And I give here a link for a 6-minute video, which is spectacular. I have it here, but I'm not going to show it. So this is the kind of thing that you would see in the field. I think this is actually in South America. Look at the left-hand side. It's a beautiful fossil skeleton of a whale. And then they were constructing a highway in South America, and they found this place which got the name Cerro Balena. And there were a huge number of fossil whales. I would call it, in a way, analogous to what you would find at Dinosaur National Monument in Utah, where, in this very localized area, there's all these different dinosaur fossils. So what we're going to do now is we're just going to walk down history. So the first one I want to comment on and look at the scale bar is Indohyus, and this was discovered by Thiewissen, the guy that I just mentioned. And you might look at this and say, well, this is kind of ridiculous. Like, how are you going to make any sort of attribution that this fossil is related to whales in any way, shape, or form? And it has to do with things about the ear. So I highly encourage you to go take a look at this story. And the ear, in general, the nature of the ear is something that over and over again has come up. Other great finds from Pakistan is Ambulocetus and Pakicetus. So you can, if we go back here, you can see up here at the top Indohyus and then Pakicetus, Ambulocetus. So these are all something like 50 million years or so ago. As far as the Pakicetus fossil goes, you can see the scale bar, wolf size, terrestrial, semi-aquatic. Brain case is similar to cetaceans, and the thought is that it ventured in water to hunt. Ambulocetus, size of a large sea lion, large head, hind feet, could walk inefficiently and also swim. The claim is that it swam with spine undulation and hind feet propulsion, which is kind of cool. Intermediate teeth, more whale-like, and there was a really nice Ambulocetus discovery of a very, very complete fossil. Here's Rhodocetus. So the hind limbs are being reduced. You can see that in the upper schematic, and you can take a look at this. The Astragalus is this common point to the even-toed ungulates. Then there's Basilosaurus. Like this one is pretty wild, because if you look at it on the bottom, a little bit to the left of me, you can see what amounts to like a free-floating hind limb. And Doryudon, I don't have any, big thing that I'm intending to say about each of these. I'm just trying to give you an impression of the state of the art and, the kinds of things that we would expect. And the final thing maybe that I thought you would find interesting was the direction of live birth. And what I mean by that is, do the babies come out head first or head last? Because modern day whales, they come out head last. And this fossil is coming out head first. So let's see. What do I want to say here? Reduction of hind pelvis and hind limbs. So in Ambulocetus, it was weight bearing but capable of swimming. Basilosaurus, small, disarticulated but relatively complete digits. 1 and 2, tinier lost, some bones fused, and then modern sperm whales, only a small bony remnant of the pelvic bone. And I just hope that makes your soul sing somehow. In the same way that the 23 versus 24 pairs of chromosomes, humans and other primates might. Because it's kind of a hidden coherence. In other words, if you looked at a modern whale and you weren't careful, you'd know nothing about this remnant of the pelvis. But if you knew what you were doing, you would say, "Oh, well, over the stream of history, I would expect that I ought to see transitional forms where I see the loss of the hind limbs." And the point is that even to this day, there are relics of it. And then I already commented on this, which is the motion of the nostrils. And, there's once again, there's this whole record of things that are known about this particular aspect of whale evolution. So my point here was intentionally superficial. I'm encouraging you to read the 2 articles that I posted, and that's not superficial, and it's by 2 key players in the field. But my point of the tourism was just to kind of bludgeon you with this idea that maybe Chapter 9 on the imperfections of the fossil record is no longer really the right picture. There's a totally different picture now, which is of a rather complete and coherent fossil record with respect to whales. So next vignette, what I'll do is a genomic view of whale evolution.